There's a wall of computer here. Okay, hi to everybody. Thanks to coming here this evening. Sorry for my English, as I know it's awful, but I will try to be as clear as possible. And this is the first GraphQL meetup. We organized this summer this meetup to fill a place that nobody was filling. And great, I'm happy that a lot of people is here in this first event. We will have two talks this evening. One about the backend,
pretty much,
and that Bojan will talk about this, and one about the front-end part, I think, and Matthew will talk about this one. And what can I say? Who knows GraphQL here? And, more or less everybody. Who uses it in production, just to wow. We need to talk. We need to talk. Great. And yes, because we want to create a meetup that works, and then if you have something to say, something to tell to other people, let's do some proposal. And yeah, we are a community, this is not a company. We are here for everybody. And what can I say? I've said everything. Yes? No? Okay, go downstairs to open a problem of this place. Thanks to TQ to provide us this amazing place, and I think we can start with the first talk.
Cool. All right, so good evening, guys. As you see from the first slide, my talk is mostly about how to develop and maintain a GraphQL schema. It doesn't say here, but it's pretty much Java-centric. So if you're like not interested in that, that's going to be a bit boring. But can't help you there. So yeah, I saw a few people knew what it is, what GraphQL is, but I still talk a little bit about it just for the rest of you. So what it is? It's a data description and query language. So it's not just a query language, like the name suggests. It's also a way to describe data. It gives you this. It's also a server-side runtime for executing the queries. So it's not like just the language itself. It's an actual runtime for executing queries, which means that it needs an actual server-side implementation, which is different for each language and different for everything. It gives you a type system, so it's a type thing. So in this way, you can kind of think of WSDL and SOAP in that it has types and that everything you ask for has a specification of what it is and what you can expect. But then again, when I think about it, don't think too much about WSDL and SOAP, because who wants to do that? It's storage and language independent, so it doesn't really matter where you store your data or how that works. Oh, I need to love the microphone more. Yes. Okay. So it's independent of the language in the sense that it's a spec, so it has implementation of different languages. So it doesn't matter what you have in the backend, it will work, it's fine. In this way, it's sort of similar to REST. That you can just think of it as a way to get your data. So it doesn't really matter where the data lives or how it's exposed or anything like that. And yeah, it's the spec itself was open sourced by Facebook about a year ago or so. They only went with 1.0 release just a couple of days back, actually, because up to now it was only tech preview. It has implementations in a bunch of languages which I didn't find very necessary to list, but the reference implementation is JS. It's Node. There's also implementation of other things. For my top Java one is the interesting one. This is the Elixir way. Scala implementation is awesome. It's by far the most advanced one. It has crazy features. So check out Scala implementation if you do Scala at any capacity. It's called Sangria implementation. And it has even, the name is kind of confusing to a bunch of folks. So it has literally nothing to do with graph databases. You don't need to have a graph database to use GraphQL. The query languages that those databases have, like Gremlin or Cypher or whatnot, are unrelated. This is just a way for your client to query your server. So like REST, basically in this aspect. So it really doesn't have anything to do with these storages or anything. So the more important question, why? Why do you want to do all this stuff? Well, it gives you the power to describe your data, as I said. So this is a very simplistic query. So let's say, yeah, this is the basic one that I always give. It's like if you go to their website, this will be, they always talk about the Star Wars characters. So you can, the query is called hero, so you can ask for a hero. It has a parameter, so you have to have it to tell its hero of which episode, and then it returns you a character. So of type character, where type character is this. So it has a name, which is a string, and friends, which is a list of characters, so recursive, and then it has a home world, which is of type planet, where type planet, again, has a name and type that are strings and so on and so forth. So now you know that if you execute this query, you'll get a character back, and you know what field character has, and you know what you can ask for it, and so on. So it's not like with REST, you fire a JSON response, you get something, you get a JSON response. You know exactly what you're getting with this. So what the main reason why this is good, what power this gives you, is you never over or under fetch. You fetch exactly what your client needs and nothing more and nothing less ever. So you want the hero of episode 4, you want his name, you want his home world, and within the home world you want the name and type. So you don't care about friends here. You're not asking for the friends of this thing and so on and so forth. You don't want deeply nested in this case. But this also illustrates another important point. You can ask for nested structure. So you can go deep as you want here. So you want the hero, and within the hero you want the world, and within the world you want the solar system, and within the solar system you want the coordinates, and I don't know what. So you request an entire graph of objects. This is the key thing here. So, and the best part, you get predictable results. So you get exactly the same structure you asked for. So you didn't get, you know, a JSON back. You got the JSON that's identical in structure to what you asked for. Actually, when you think about it, the query is pretty much JSON, but just the keys without the values. So this is your query, this is your response, they're one-to-one mapped. So you get a hero, you get his name just like you asked for, you get a type just like you asked for, I mean the home world you asked for, and then within that, the name and type. So you get Luke Skywalker and Tatooine and Desert. So as you see, even though we have more fields like characters and it's infinitely recursive potentially, you're not getting any of that. You get only what you wanted to get. So in a very vanilla example of a website, you have a shop and you have a cart, and the cart has products that you are buying, and products have prices, and they have names and pictures and stuff. So like, of course, there's a million ways you can model this with REST, but something not too out of ordinary would be that you have a cart endpoint to fetch the current contents of cart, and that would have IDs of products that you're buying, for example, and quantities or whatever. And then within the product, you would then maybe have a dedicated endpoint to a product. And then you would ask, based on the ID you just got from cart, you would then fetch the products by ID, and they would have prices, and they would have names, and they would have links to pictures, URLs to pictures, and then you would download pictures and blah. So this is too many round trips. And more interestingly, okay, it's a lot of round trip. That doesn't by itself have to be terrible, but from the product, for example, you don't need the entire description, which could be big. You just need the title, for example. But you're fetching description anyway, because that's what your endpoint does. More interestingly, even than that, is say you want to add something to this view, suggestions based on the current content of the cart. So you want to say, oh, you like this GitHub promotional stuff, so maybe you want, I don't know, something else. So you want to add suggestions. How will you do that? Well, you could have yet another endpoint to that can offer suggestions based on the IDs of current cart, or you maybe put it in the cart. Maybe the cart itself will already contain suggestions as well. So you kind of expand that. Depends, you can do things. So how you do that? So you could do something like carts 1, and then maybe expand the products to fetch all the products within the carts. You could do that, I guess. You could do something like this. This is similar to Fulcrum, by the way. This is like a different technology that Netflix guys open source. So this is kind of similar. So what it does is basically it says, yeah, I want this, but then within that I want the products, and then within those I want these, but you know. So you could do something like that, and then as long as it's like, you know, reasonably shallow, it works. But if it's too deep, then it's again unmanageable. Then you can have a custom endpoint, which is what most people will tell you, like cart with all the stuff I need, make your endpoint. So it gets stuff. But then of course you know, life moves on and you introduce more stuff, and then your clients don't know that, so you end up with a version 2 cart with all the things. So that's great, right? And there's another thing where you want the exact same things but without the description. So what do? You make yet another one with cart with all the stuff and no description or something? So yeah. But let's even ignore that for a second. So let's say that's fine. You still have a thing to, every time you want to add any of these or modify any of these or do literally anything, to change any way. So for every view change, you need to do changes on the server. You need to update your endpoints, like create new ones or create versions 2 or whatnot. You also need to update your models, because if cart now has suggestions, then probably your backend needs to change to have suggestions in that thing modeling the view now. Then, of course, many of these are kind of solvable by APIs, which gives you ways to browse things. It doesn't help with the multiple requests, but it does help with discoverability and things like that. It also makes your payloads horrendously big, because you have to describe everything extra. But then it also, even with that, it doesn't tell you what the client is getting. So you still need like a JSON schema or something on top, so the client knows what to expect. Otherwise, it's just a blob of something. So it's like all this kind of thing. Whereas you could just do this. You could just say, I want a cart, I want total, I want the products, and within products, I want the names and price, and that's it. I don't care about descriptions, so there's no like all the stuff I need with descriptions and blah. You just ask exactly what you need, and that's it. And that's exactly what you get back. You get your cart like you want it, you get your total like you want it, you get a list of products, and they have what you want them to have, and that's it. So this is kind of it. So, as I said, GraphQL is not just the query thing. There's the whole runtime on the backend to execute all this, and it's kind of gnarly when you think about it, especially in Java. This is how you do that, because you need to define your schema programmatically. You can't just describe it in a document like a JSON kind of thing. It has to be done programmatically, and the reason for that is every field and everything needs a resolver function. So you actually have to write a function which you can't serialize into anything, because different implementations, and you couldn't just do that. So, and this is how it looks in Java. So this is the GraphQL Java implementation. So you have a nice builder pattern going on. You want to describe your product now, which is a sort of simple type. So you create a new object, which is called product, and then, object type. And within that you have a field. Field is a name, and it's type string, and then you build that field. And then another field, which is price, and it's of type float. Don't do price as a float, by the way. So, and then you build it, and now you have a product type. So, now you have your cart type, as we described. So you have a cart, and cart has a total field, which is a float. And then that needs how you fetch this, how do you resolve this? I don't know why in Java implementation is called data fetcher. In literally every other implementation under the sun is called a resolver. So just mentally translate data fetcher to resolver, and you'll have better time. So you have to say how you resolve this, how you get a total. So maybe you will, get all your products and then get all their prices and then sum them up, for example. That would be a reasonable assumption. And then you have the actual products field, which is a list of products. So here's the definition of product. So this is a list of products. So we now know, it's a list of products. So we have these fields. And so now you finally constructed your cart and your product. And finally, you can make your query. So how you define that? You say that your query is also called carts. So you can call it just by saying cart. And here it assumes that there is one cart for you. So you don't have to say cart with this ID. It's like your only cart. So that's the assumption. It takes into account that you're a logged in user which has a session that he can get who you are. So the query is called cart, and it returns a cart. We just define it. And how does it resolve this? How does it resolve the cart? Well, it could have some, card service where you can get the current card to the currently logged in user or something. So this is like normal Java call to something. So all this you needed to do to define that endpoint. So, which is sort of more or less okay, but you had to define, this is I think the key takeaway, you had to define that there's a product type, that it has these fields, that they're of type string and of type float, of course. And then you have, then you have the exact same thing in Java. You have your cart again, and it has a float total. Just like we said a second ago, we have a total which is of type float. So we repeat that. Oh, I have a cart and it has a float of, oh, I have products and that's a list of products. Exactly what we said a second ago. And then a product, oh, that also has a name that happens to be a string and a price that happens to be a float, which is just what we said again. And then here's your cart service that you call. So this is your cart, this is corresponding with this type here, and they're very identical, just this is expressing the cart in the GraphQL type system, while this is expressing the exact same thing in the Java type system. And then you have the data fetcher, so resolver. So this is it, this is the function that you're calling, so that's fine. So what does it mean? It means that you need to duplicate a type definition for everything, all the time. So for every field of every domain object that you have to duplicate that and say it twice. Say it in the Java type system, say it in the GraphQL type system. And that also means when you change one of those, you need to change the other. So that's another layer to maintain. So every time you add something, you go back and then add it again, and then, you know, it's a, so if you're thinking to yourself, like, holy shit, that's disgusting, you would be very right. Because it is. So here's a solution to that. Dynamic schema generation. So basically saying that you should just eliminate type duplication because now you generate your schemas. You no longer define them by hand and then again and again. You will just see your model and then define the schema. So eliminate the duplication. You also can smartly nest logic. You'll see in a second what I mean by this, but basically that you will get to keep your separation between your stateless services, your singletons that have logic, and your anemic domain model that just has a domain model, so you won't have to cram and do weird things. Although if you're a Rails fan, I guess you're used to that, but don't pay attention. And it also, for this to actually be a solution, because sure, you generate the schema, but if it doesn't adapt to the code you already have, if you go and redesign your entire backend to fit this, then it kind of didn't help you at all. Also, if you can't customize it because you have other things that don't fit in, then again, it's not a solution. So if it makes you intersperse your logic with your domain, it's not a solution. If it's making you say everything twice, it's not a solution. If it's not adaptable to what you already have, or it's not customizable, then it's not a solution. So we present you, a solution. Our cool library called SPQR, which does this. And then I'm presenting to you again, because we have two logos, because we're in the design process, so that happens. So what does it do? We call it SPQR. It stands for Schema Publisher and Query Resolver, but of course it's a non-situation term, so if you figure it out, you can patch yourself with that. So let's say you have normal Java code. So this is your person service thing. It's a stateless service class that just does something. So this is a very simplistic example. It accepts a person object and returns a customized rating for that person. So let's say something you could display on the view. So you have that in your Java. So what do you do to expose this as GraphQL? You just say it's a query. Actually, you don't even have to do this if you're happy with the name that it has, get rating, then you don't even have to do this. But let's say you want to change the name and explicitly expose it, then this would be the way. So you just say, now this is a rating query. And that's it, that's the entire thing you have to do. Let's say you have a more complicated thing. So here we can get a bunch of people by name. So we're accepting a name, which is a string, and then we do some database query or whatever you do to fetch people by name. And you return a list of persons. So you could again just slap an annotation on it and call it people by name query, so now it's exposed with that name. And let's say you want to customize the parameter name. So parameter is called just name, but you want to expose to it to front end as first name, for example. So you can do that with this argument thing. And this is what you need to do to set up. Oh yeah, your person domain object just looks like a normal Java module. Nothing interesting there. It's just a bean. It has first name, last name, and it has this. So again, you technically don't really need these annotations at all. It will work without them, but it's good because maybe you don't want to expose every single field, or so then you put these annotations and then tell it to expose only those, and you maybe want to change the names of fields and so on. So this is how you say what you can get from the person. So once you call the previous query, which is to get a bunch of people, then what can you request deeper in that structure? You can get this first name and last name that people have. This is what you need to set up your backend. So verbatim, this is the entire thing. So you create your person service, which is the class you just saw a second ago, this one. I mean, you create it or you inject it with a framework or what you do. If you do like Spring or something, then just inject this as well, it doesn't matter. We don't care what happens as long as you have an instance. You instantiate the schema builder, you register all these classes that you want exposed. So within it's called query source. So basically where your queries come from. So you're exposing this is a singleton bean as the name says here, and you want to use that as query source. So expose all the methods that we find in that one. So these ones, this will be exposed. And that's it, you're done. That's the entire GraphQL thing. You just say what beans you want exposed and done. Then this is the standard GraphQL Java thing. So this is basically instantiating the actual GraphQL runtime. So this is the thing, this is the reference you want to keep around for the lifetime of application. This is what is executing the queries and what's doing the bulk of the work. So now you can execute a query. So let's make a query. Let's say we want people by name. So that this name now corresponds to, oops, sorry, too much, too eager. So corresponds with this. So we expose the query with this name, and there's one argument called first name, just to remind you. So then, oops. So what you do here, you're just constructing this as a string, just nothing. So you say you want people by name, you want first name, that's a parameter, so you say first name is John, and then from every result you want the first name and last name. And then you just execute it. So this is, again, the reference to your runtime. So this is the thing that is executing queries. So you just say GraphQL, execute query, that's it, you get your response. So it will invoke the correct method, it will serialize everything correctly, and do it. So, but that's still not showing some key things. For example, let's say your person service can now do this. You can get a Twitter profile for a person. So you pass the entire person object, and you somehow do something, look it up, construct a Twitter profile somehow. So you do this, and you expose this as a Twitter profile query. And then here, this is the same query you saw. So it's people by name, it gets people by name, it's the same thing. So, to call this one, you do this. So Twitter profile. It gets you need to pass an entire person object as an input. So here's an entire person object as an input. And then you want a Twitter handle, and you want the number of tweets from his profile, from their profile. Well, his. So you pass the entire person object, just like it says. You get back Twitter profile, which has handle and number of tweets, for example, and this is fine. Then to invoke this one, you again say people by name, first name John, first name, last name, you require that, and it's fine. But what this means so far is that if you would execute this one, you would get people with name John. And then to get their Twitter profile, you'd have to go and invoke another query. So another round trip. Now you fetch the person, so now you go and get their Twitter profile. Which, if you noticed, exactly defeats the purpose of GraphQL. If you're doing it like this, because we said the point is to not have to do round trips, but to be able to request an entire structure that you need. So ideally, you want this. You want to say, yeah, I like people with name John, and then I like their Twitter profile, and then we did that, I want this. So what does this mean? That you have to go and change your person object to now have a get Twitter profile on it, and then, you know, like we did here. Sorry, here. So what would you do? Like, have another query that says get Twitter profile, and then cram that into your domain, even though it has nothing to do with your domain? So of course not, you're not going to do that because that's their role. So what you do is you just say this. That's the entire, this is what happened if it wasn't confused. So just, you add this annotation. So what this means is that now this person object can come from the parent query. So it can come as a result of the parent query. In this case, this will be the parent. The people by name is the parent query. This one is embedded, so it means that this one will provide persons, and then this one will just get the person that was the result of this one. So that's it. That's it. So it keeps your logic completely separate from your domain. It doesn't want you to, change your domain and then put ugly things in it and, destroy your nice architecture. So it doesn't do any of that. So that's what I meant by smart LNS logic. Like figure out where your logic is, figure out where your domain is, figure out how to connect them together. So it makes sense. So this gives you, this is enough. So and it figures it by type. So basically this is returning persons and this is accepting persons, and it has this annotation, so it means these are connectable. So it means on the result of this you can require this. That's it. That's the entire thing. So that was for queries. You saw approximately how to deal with queries. Now for mutations, it's thankfully identical. There's literally no difference, except that you say that it's a mutation, and the only reason it's there is so that it's obvious. So you know this one will cause effects. It will change stuff. So everything is completely identical. You just say mutation, and you give it a name, same thing. You will accept a person, and you do some insertion or whatnot here. And for the client, the mutation looks absolutely identical, except for the difference that you have to put a keyword mutation. That's the only thing. You have to say, basically the client needs to be aware that it's doing a mutation, that it's changing things that it eventually changes, and not something you want to repeat, for example, or something like that. So it's very explicit in that, and it's very nice. But syntactically, it's one-to-one, there's no difference. So, how do we invoke it? Exactly the same as before. You call insert person query, here it is. You give it an entire person object as an input, here it is. And the coolest part to note here is that every mutation is also a query. So you did something, you inserted a person, and now you immediately want their Twitter profile back. So somehow in backend, somewhere here, we assigned them a Twitter profile or we did something. So you insert it, and then you immediately require something back. So no round trip again, no insert, and then you get the 201 that yes, I inserted, and then fetch it again, and then you do things. No, you can do it in one go. That's the beauty of it. So, yeah. So, demo time. So, I'll try demoing this shortly. Let's see. So, there's this GraphQL tool. So, GraphQL tool, that's a Facebook tool that you can use to explore your schema. Can we get a little bit bigger, the font, please? I guess so. Yeah, but one hand. I'm kind of, Is this better?
Yeah, thanks.
Cool. All right. So I'll do a refresh because there's a reason to do that. So the thing, the tool itself, this is Facebook's own tool for exploring schema, for firing queries, so you can do all kinds of stuff. But the thing I want you to see here is this, because this is a thing of Marvel. So basically, within every GraphQL runtime, there is introspection ability. So just like you have reflection in Java and other languages, GraphQL has introspection. So basically, you can fire a query that will explain what the server has. You can ask for all the available types. Just like, for example, in a SQL database, you can say, select the tables from schema and something, and it gives you all the tables, and then you can see the columns in those things in the tables and the types of columns and so on. So this is the same idea. Basically, you can introspect the model, so the schema. So you can say, give me all the types and their fields and everything. And so basically, the beauty of it is the client doesn't need anything at all except one single endpoint. They know how to get everything that you can return. They know every single query that they can fire. They know exactly what every one of those will return. They know every parameter they expect. They know what's optional, what's not. You literally give the client everything they could possibly want to know about your domain. just by giving them the endpoint. So no extra, stuff. You just give them an endpoint, they know how to introspect it. There's no need for like heteros kind of stuff, where you one step at a time, you say, oh, on this you can go then here to request more. You just know everything. You can now require as deeply as you want from this. It's basically a contract, just like Weasel is. So again, I'm sorry for invoking bad memories of Weasel, but it's kind of like that. It has the good sides of Weasel in that it's a contract and that is there. So you can just, when you open GraphQL, it will immediately show you the entire schema. So this is the mother of all introspection queries. It fires the biggest possible introspection query that gets everything about everything, and then it shows you here. So let me see what happens if you press here. I think it should generate, or maybe it doesn't. This is the version of GraphQL that I'm using, by the way, is pretty old by the JavaScript tool standards. So it's like a month old, which means that there's 15 versions ahead of it. And I know the Scala guys from Sangria, they did a lot of improvements, so it's actually much better these days, but I just didn't get time to upgrade it. So you can expect a bit better experience, like with tabs to fire multiple queries, and it also has like a place where you put headers if you need extra headers for authentication and so on. So it's actually better these days. So I'll first show you, or at least I'll try with one hand or something. Or I'll do this. I want to show you what this looks like in backend, so you know what to expect from this in front of you. So
I think you can pinch.
that is probably true. And the best part is you can do it with one. Cool. Okay, so this is my backend. This is a ridiculously simple Spring MVC application. It doesn't have to be Spring in it by any means. There's nothing Springy in this, but it could be just a servlet or whatever. But it's Spring MVC. So what it does is it creates a builder, just like you know by now. Oh yeah, there is one Spring thing about it. All these service classes are injected by Spring. So there's no new or anything. So we just inject, which means, which also has an important connotation to it actually. We're injecting it by Spring, which means all the Spring magic still works. So if you have interceptors that, I don't know, do security, or if you have any AOP style or anything, it will still work. So you can still do your security the way you do it, and everything remains exactly as it is. So, you just call your Spring beans just like you always would from your normal backend, nothing changes. So I'm registering all these are just stateless service classes, nothing special. They're explicitly named queries so that you know there's queries in them, but that's it, they're just normal classes with, stateless and just logic. So, yeah, it will create all of these, register all of these. This is not strictly necessary to do, but it's sort of nice to say. It means that I should note, I guess, briefly say, there is a notion of an extractor. Extractor is the thing that decides what's a query and what's not, basically what's exposed and what's not. So the default one is the annotation-based one, so they're all exposed methods that are explicitly annotated. It won't just expose random things. But you can customize this, so you don't have to have annotations. You can expose everything that starts with a get, or you can expose everything that's public, or whatever, custom logic, everything that has a certain name or a certain custom annotation. So, oh yeah, that's important. Any custom annotation, which means it could be already annotated by a different framework. You can reuse all that. So that does. So it uses this. There's also like another extension point where you can influence the way all your Java classes or all your Java types are mapped to GraphQL. So you can influence this. You can also convert values dynamically and whatnot. But this will just do the defaults. So it will just do the logical thing. And that's it. So we instantiate the runtime. We're done with the schema. We just instantiate the runtime, and then when GraphQL will hit this endpoint. So when it hits it, it will just get the query from the request and then run it and then check if there's any errors in the result. If not, serialize it to Flutter. It will serialize it in a bit different way. So this is the entirety of the backend. Oh, fire and actual. Oh, I think I have to try that. So I'll fire a. This is a super simple query, so I'll format it a little nicer. Oh yeah, this thing does indentation automatically, which is very nice. Well, mostly.
Good. Talk about there.
Cool. Yes. Yeah, I mean, it's a simple one. So it just gets a vendor by ID, and it gives it ID of 0, and then yeah, we get the name and we get the address. So vendors have addresses, and addresses have postal codes, and so on. So we can fetch this. We can. I'll show you for a second the Java equivalent. So what happens in Java stays in Java. So yay! I learned how to do this. So this is the get vendor. So we have an ID argument which happens to be a long. Of course, it's a moment here, but it does something. There's also a mutation, create vendor. So same style, we pass a vendor and it creates it, and then we can ask for it back, which I'll try doing now. Mutation. Cool. So create vendor, we pass the entire vendor object with all the So the entire hierarchy nested everything, and then we ask for stuff back. This time a little bit more things. So, it's hitting a breakpoint, which is good. It shows you that it's not mocking what it's doing. So it does hit the Java backend. So here, it inserted the vendor with ID 1. Oh, shit, I gave it the same name, but okay. So we gave it, other details. So let me try asking for that vendor again. This new one now. So I get a new guy, and well, same postal code, so not particularly entertaining, but yeah, okay. So that happened. So you can basically use this. I'm not even going to talk about variables because yeah, it's a thing you can just read about. I mean, it's basically that you can reuse queries just like you do in a prepared statement with a SQL. You have your query without the variables, so without this one being hard-coded, and then you can pass in a separate object containing all the variables. So basically, just like a prepared statement or something like that. So you have the query that is reusable, and then you have the modifiable things like the variables in the query passed separately. But that's it. I mean. So yeah, this has a nice editor for the variables and for the queries, and you can see the schema. So it's a very nice tool. And as I said, it's actually nicer now. So if you go and use it, it will be nicer. So let's go back to this. So just a little touch on the advanced topics. I mean, advanced. So for example, authorization. I've had people ask a bunch of times, like, yeah, but how do you do authorization? Well, the same way you always did it. There's literally no difference. So if you did, I don't know, Spring Security or something, you keep using Spring Security with its annotations, it would be respected because it just calls the same Java method that it would normally be called, it's fine. But you can also, for example, your methods might need some shared context like the currently logged in guy. It could happen. So you could do things like this. Let's say you get your current user by whatever means you do normally, you get your current user. And then you can provide this thing here, this extra parameter. So when you're executing the query, on top of the query, you can provide an extra parameter, which is a shared context. This context will be propagated down to every single resolver that gets triggered. So go back for a second. So every single field has its own resolver. How the field is resolved. It could be super simple that it just calls a getter of the object. or a key in the map, then in that case you don't even need to specify that resolver. But if it does something like invoking a method that goes to DB or it does something, then you register. So every single field that you ask for, and technically queries are fields. Root queries are fields of this root, like this magical root query object. So every query is just a field somewhere. So every field has a resolver, meaning every query has a resolver. And this context will be propagated down to every single resolver in the chain. So you could, for example, put the currently logged in user as the context, and then everything will have access to the currently logged in user, so our methods will do something with that. That's one thing that's sure.
Is that stock GraphQL?
Yes. Yeah, that's stock GraphQL. The only thing is there's an annotation for injecting that into your methods, so that the magic happens of connecting those two. But this is just stock GraphQL. And this is the truth not just for Java GraphQL, but for every GraphQL implementation. It's the spec thing. Second thing that people very often ask is how you deal with transactions, because now everything is sort of different. Now the client is in charge of what gets triggered and what gets called. It's no longer your controller method, for example. It's no longer orchestrating what is getting called. It's now client, because they construct the request and what, to the nesting level and everything, so they're the ones in charge. So how do you model transactions now? There's not one answer to that, but a simple thing you could do is just grab this, run this entire thing in one transaction if you want that. That gives you an all or nothing, semantics. So basically, if anything within your any resolver breaks, you get nothing, which might be fine, but probably isn't. Otherwise, you just keep your transactions as they are, and then it's what the result of that will be is that if any of the queries, any of the resolvers fail, in the results you will get nulls for those, but the rest of the things you requested will be there. So you will get like a partial answer. Everything that worked, you will get it. Everything that failed, you won't get. So that's you choose basically what you want and where you put how you demarcate your transactions. So it's one of those. And then there's a file upload. This is a tricky one. This is particularly dirty. Because how do you upload binaries? How do you upload a file using a mutation in GraphQL, for example? There's not a nice answer to this, but again, you can just abuse the context again. So instead of injecting the current user, you can inject the HTTP request, the current request. And then from that, then your method that knows what it's doing, you will expect to have it there, and then it could extract, for example, the binary and stream it from there, or do something like that. And in the reference implementation, they have a bunch of examples, and this is exactly what they're doing. They have they're using Express to have this example server. And they're doing the same thing. So this is basically how you do that. It's not particularly nice, but it's sort of okay, as long as you know what your root thing is, as long as you know what your context is. And this is the coolest problem, I think. There's the complexity. Meaning that now, again, you have client in charge, which means they can require an insanely huge structure, including infinitely recursive, thus infinite structure. So what do? You destroy the server and die in fire. So you have to deal with it somehow, because, So the simplest option that you can do, but you can only do it in case that you are your own client, so you're not exposing your API to third parties, just to your own front end. And this is what Facebook is doing internally, by the way. They just write with queries. So they don't even send queries from the client anymore. They just send ID or name of the query, and then backend simply knows what that means. So if I say get vendor by ID, it just knows what it means. There's no entire thing, and it knows what it wants. So you can do this, and then you just have trusted queries, which is fine in some cases, some not, depending on your use case, but it's like simple. This is probably the most interesting one. So you basically would have to wait for the entire query to be parsed into abstract syntax tree, and then you can run complexity analysis on that. And then basically see if you can figure out how complex the thing requested is, and then have a cutoff, and then say this is too complex and not running this one. Just return a 400 error or whatever you do. And or you could also do a third thing. You can, if everything is running in a transaction, for example, you could also just limit execution time. So you say, oh, this transaction has been running for more than 5 seconds, and just kill it because you're doing funny business. So you can also do that. So the thing to keep in mind is that it's super new technology, so there's no best practices really. We're kind of just trying to come up with them. So you'll find different ideas, and which is also kind of cool because you can come up with something new, unlike with most other things. So there's that. Yeah, I'm actually working more or less with the Java guys, the GraphQL Java implementers, on adding a hook when the AST is parsed, so that you can at least hook things there, because it's useful for two things. If you had a parsed AST and then you could do custom logic, you could, for example, decide based on the current query what your context is. You wouldn't have to have like a dumb, all-encompassing context that works in all cases. You could actually be more smart. And you could run complexity analysis and so on, so you could do intelligent things there. So there's that. And there's the elephant in the room, I would say. CEO. I really have no answer to this. I have no idea how this affects CEO, but it sounds terrible. Because if you have a single page and now you don't have even the nice URLs that crawler can figure out, rest you just fire posts. It's just posts most of the time where you're posting a query. So now you have postbacks all the time, just like JSF or something that everybody loves like that. So it's probably bad for CEO, but I'm not an expert on CEO, so I can imagine it's terrible. I don't know the answer to this one. But I guess it still depends on the use case a lot, because if you have maybe you don't have a single page application, then it's not a problem, or the application is behind the logging wall anyway, so crawler doesn't see it. So maybe it's fine, maybe it's terrible, I don't know. Check your use case basically. Roadmap for the library, yeah. And again, I'm forcing you to think of WSDL. So, it could auto-generate the clients, just like you would do with WSDL to Java. You have the contract now. You have the entire schema. That's your contract. So if you were doing server-to-server communication, you could just generate a client that already knows and has methods for every single query, and then you don't construct queries. You just call nice Java, for example. That would be kind of cool, right? You could. This is really interesting, by the way, because if you think what the thing is doing, you just register a bean that you got from somewhere. It could do auto-discovery. You could just drop a jar and it could go and search through it and then find everything exposed and expose it, which is a super advanced and super cool use case. I think it's just without redeploying it, you could just deploy another service, another component somewhere, you could discover and expose it, and then you suddenly have a new API. It's kind of nice. I really want to do this one. Because, as I said, it's completely customizable how you discover what's a query, what you expose. So, why not just use existing annotations of a different framework? Let's say you already have your REST endpoints done using JAX-RS, for example. And you're doing it with the normal JAX-RS annotations, get the post, blah. So you have all these, so those are the methods that are exposed to the client. So just tell to your GraphQL schema builder that these are the ones you want, not the GraphQL query ones that I showed you, but these annotations, and that's it. With zero effort, 0 lines of code, and literally 0 overhead, you just got a API, GraphQL API, identical to what you had in REST. So you have your REST API, you do nothing, and then you get a GraphQL API in it. How awesome is that? So, yeah, I mean, if you just want to try it out or anything, 0 effort. You just have the entire thing. You keep your cake and you eat it too. So I really want to do this one, and yeah, I'm doing this one. So the next thing, I guess, would be support for subscriptions, because GraphQL just got cooler recently. Well, not completely, because this is still not really in the spec, but it's almost in the spec. So basically, everything you saw right now is, standard. Client fires a request, fires a query, gets a response. What this gives you is a way to just subscribe to something, so you want to push. So you say, this is my query, but if the result of this query will change, you tell me. So yeah, you get a push thing. So I don't know how this will affect the library, because it's still not in the spec. I still don't know how it will work in the GraphQL Java, the underlying library, because it still doesn't have it, so I don't know. But it will probably have to affect the library somehow. And then, whatever code comes to mind. So, question time, last time. Anyone? Anyone at all? Yes, please.
Yes.
Should I use the mic?
Let me do that for you.
Oh, well, you're up.
Thanks. So I was wondering, you showed an example before where you were returning some errors.
Sorry, Train?
You showed an example before where you were returning some errors.
Yeah.
How are they implemented in GraphQL? Is there a specific solution for error handling?
Error handling.
Yeah.
Yeah, mic thing. Sorry. So, the thing is, it kind of depends on what you do, but in most of the cases, if a resolver for any of the fields throws an error, it does not stop the execution of the query. The query keeps going, showing what's going on. You just get a null for that specific field. So if you have a deeply nested hierarchy, you wanted all the users whose subscription is expiring tomorrow and then their addresses to mail them. Let's say something in the resolution of addresses failed, you would still get most of the response. You would just get nulls there for the ones that failed. This is the default behavior that you will get if you don't do anything. Now, of course, it also depends on how you deal with your transactions. So if you had everything, then it will propagate and kind of destroy everything. So it kind of depends as well. You can choose, but by itself, it will. If you just do what I did now, it will just do this. It will pack. Also, you will get the errors as well in the response object. So it will tell you the reasons for errors and so on. So you can render it to the user and say, this happened, and explain why you got nulls and things like that. But it will still get something, which I guess is good. You could, of course, just not do that because once you get the response object, you get both the result data, so the successful result data, and the errors. So you can just check if there's some errors. You can decide to not send anything to the client, just send the errors. So it's kind of up to you what you do. But there is one kind of thing that I would agree, I think is kind of ugly, which is you can't really distinguish between, like a 404 and an error that easily, because it's a null in both cases, I guess, or maybe not, depending. Maybe if you throw a null pointer, you decide to show the client a 404 or something. So it's more up to you. It's less defined for you. It's not like a resting where it's pretty clear if you get this error, you send this code. It's more like, yeah, you do what you kind of want, kind of deal. Did I answer?
That answers my question.
I'll wait around.
So, to catch up with the previous question, so errors wouldn't be exposed to the client?
Sorry, the error.
Yeah, the errors would not be exposed.
With the,
Sorry.
You are pretty loud by yourself. I think
I
you
know,
can do
I know.
without, and I can just.
I can totally do without.
Maybe you can just repeat the question. So.
Oh, that also works. So, will the error be exposed to the client? So, with the way it was implemented here, it would, because we explicitly did that. So, with the way it was done here, we actually explicitly check for errors, and then we do send the errors to the client. So if there's any errors, we don't send the result at all. So if you find any errors, this is how it's done here. You don't have to do it. But if there's any errors, just send nothing, just send the errors. So yes, they would be exposed, but only if you want. Because you get this execution result in, it has both the successful result data and the collected errors. So you decide what to do with it. You can translate the errors, to show a friendlier version of them, or not show them at all, or show all of them. So it's kind of up to you what you do, really. It's outside of the library itself and GraphQL itself. It's more like in this web context, because it doesn't really have to run in the web context. It just gives you what happened, and then you see what you do. Is that an answer? Or?
Yeah, and the second question, I thought that you could not.
You can repeat it as well.
Yeah, okay, you say it, I'll repeat it.
I thought that you could not do something like select star just to select subtree of your query.
Good question. No, you can't. So there is no equivalent to select. So yeah, repeating the question. The question was, can you do select star, something like select star in SQL that would be select the entire subtree that goes from here? You can't. You have to explicitly end the query on a leaf, which means either an enumeration, GraphQL has enumeration, or a scalar, so like a integer string something. you cannot finish with an object. You cannot just get an entire object. You have to, you know, specifically select the fields you want. It has to do that way.
That's good.
That's actually a good thing, yes, because it's harder to create one of those evil queries that requests, you know, the universe. And then, yeah, it's still possible, but, you know, at least it doesn't make it easy. So. Sure. Anyone else? Yes, please.
Do you have any experience with caching?
Pretty good question. I forgot to include that in the advanced topics. A little bit. The thing is, there's two strategies that you could employ there. They're vastly different, and you know both are kind of good. So what you can do is not use the. There's this notion of execution strategy, so how you run through the queries and execute them. What it will do by default is it will run all the queries that are on the same level. It will run them concurrently, and then their children concurrently and things like that. But it means it will trigger the resolver for each. So what you could do instead, it's not caching, but it does solve the problem that you were probably having in mind, which is the n+1. What it will do is you have a batching execution strategy, which will basically see all the things of the same type that you requested, and then just remember sort of that you requested them, and then fetch them in one go for one level of the query. So this prevents n+1. On caching itself, it's really, really different in the sense that the strategy for caching is widely different than what you would do in REST. In REST, you would just cache the entire thing. Like this is the request, the URL, and I see that URL before, so you return the entire thing. Here you would do a much more fine-grained caching. So basically, you could cache on the level of one resolver. So say if you're now, you know, if you request, I don't know, 5 people by some criteria, and then 5 more, and the 3 happen to be the same, you can, you know, get just those 3 cached and then execute the rest. So it's much more fine-grained. You can also do this on the client. There's many really smart front-end clients, like Relay is like super smart, but it's full of black magic as well. So it's so it knows to keep it internally keeps a track of everything you requested by ID, because it knows an ID, it has like expectations of your schema. So if it keeps a cache of everything that's requested by ID, for example. So you can do really smart caching, but it takes more effort. It's not as simple as in REST, where you just, you know, you see the URL, you're returning. So yeah, it's on the more fine-grained, so in one sense it's more powerful, but in the other it's more complicated. But that's how generally you would do that. So there's those two ways.
So I'm curious about how expressive the GraphQL language is, and it smells a little bit of type systems and of RPC. And for instance, can you say you have a user object type with list of friends?
Yeah. And
can I ask all the users which have exactly 4 friends?
The thing is, you could, but it's completely your own definition. There's nothing to, how to say, there's no operator like greater than or exactly. So the parameters that you're giving are just dumb parameters, and how you interpret them is your own thing. So you could have, for example, if you had a query like that in your backend, one of the parameters that you're passing would be like number of friends, and you would internally then understand it as the maximum number. So it's really like, it just gives you like the language, it just gives you a way to ask for things, but not really how you interpret the queries. That's really up to you. So you can have any kind of parameter in the query, and you can interpret it any way you want to. Yes, you could. And then you can maybe your query would look users, parameter, number of friends, or maximum number of friends for. So you have to have a dedicated parameter for that, for example. Or have a query that says get users with not maximum number of friends, or something like that. So it's really up to you how you do it. So yeah, you can do that. It's just not really, you know, it's not like SQL just giving you a way to request something like that. It's just hooks into your backend, whatever it is.
I'll say one more question, and then we move on.
Sure, go ahead.
Beyond the backend, is there a way to prevent GraphQL injection at GraphQL itself, or maybe SP level?
You mean, I understand. You mean if you would like post like a malicious query or something, or inject it somewhere? I've not thought about that, but generally it shouldn't really be doable easily for the pure reason that you don't really have like a, you know, in a normal web page you have like a bunch of input fields and then, you know, in those you do things. Here, those will be serialized parameters to your methods. So you would get like, sure, your methods that expects a username might get a weird string, but it's not going to interpret it in any way because only the top level was interpreted. So I don't think you could do anything particularly interesting, but you could blow up, for example, the deserializer that's trying to deserialize what you have, then it blows up. So yes, you could probably do things like that, I'm sure. But then again, it comes back to exception handling, how you deal with that. So yes, you should pay attention. Actually, you could make evil things that explode the serializer. The speaker library is by, you have options. It's by default using JSON or Jackson. You choose and to deserialize. So you could trick those, for example, to blow up and do evil things. That's totally possible because they're creating objects out of nowhere and using reflection. So I'm sure you could do evil things there. So yeah, there seems to be a possibility.
Well, I think you can prevent it by using the whitelist.
Yes, of course, yeah. Whitelist kind of helps with many things, but it also only works in some cases. Because yeah, if you're exposing the endpoint, you're exposing your API to third parties, then you can't really do that. But in a normal, let's say,
you would do that for us also, because it also usually deserializes JSON.
Yeah, you have the same thing, but it's, yeah, okay, it's kind of like that, so sure. So yeah, that's what I can come up with from the top of my head. It could be a problem. There's probably more to that, but yeah.
But does it do in the case of threads, for instance, is that the payloads are not dynamic, so you know if you have something that you need to encode, for instance, if you do something like a sample.
Yeah.
But in that case, you can't really tell what the heck is.
You mean in the input?
As the output.
As the output. As the output, by itself, it doesn't give you, I mean, you can, because you're in charge of writing the resolver for that field. So your resolver can totally encode things as a result. In the terms of the speaker library itself, you could do that by registering a conversion, a custom converter. Then it will take whatever the output of the method and then do something to it. So you could still do that. So just keep in mind that, yeah, for every single field everywhere, you're in charge of how it gets resolved. The default behavior is it's just, you know, if there's a parent object, just call a get on the parent object. But you can do anything. You could plug in any custom logic for it. Encoding, prevention of something, you know. If you have like a Spring security thing that will check the posts authorize, if you didn't fetch something you shouldn't, it can still work the same way. So it's yeah. It still does its thing, so you could do AOP style or anything, it would still work. Okay. So I guess we're out of time. So
yes.
Thank you kindly for listening to me. Hope you and no, don't work for it.